Welcome to the session of simple pendulum. In this session, we are going to find the acceleration due to gravity at the given place using simple pendulum, and we are going to find the percentage error in the observations. The aim of this experiment is the apparatus we are using in this experiment is a simple pendulum consisting a bob with torsionless thread, a split cork, retard stand, vernier calipers, meter scale, stop clock. A simple pendulum consists a heavy mass, which is a bob, tied with torsionless thread, and the other end of the thread is passing through the split cork. The split cork is fixed in the retard stand tightly. To determine acceleration due to gravity at a place, we use the formula small g is equal to 4 pi square L by T square. Here, L is the length of the simple pendulum. Capital T is time period of oscillation. Small g, acceleration due to gravity. Here, small l, the length of the simple pendulum, is considered as small a minus small r. Here, small a is the distance from the point of suspension to the lower end of the bob. Small r is the radius of the given bob. Small a is measured with the help of meter scale, and the radius of the bob is measured using vernier calipers.
Let us describe the vernier calipers. A vernier calipers consists of a rectangular metal strip S. This metal strip has a fixed jaw A at one end and a scale graduated in inches on upper edge and in centimeters along the lower edge. This is called the main scale. There is a rectangular metal strip which slides over the metal strip S. There are readings on the lower edge of this strip. This is called vernier scale. The jaw B and A is used to hold the objects. Jaws C and D is used to measure the diameters of test tubes and hollow bodies. Strip S to measure the depth of the holes. Now, we measure the least count of the vernier calipers. Least count is equal to length of one main scale division by number of divisions on vernier scale, that is equal to 0.1 by 10, that is equal to 0.01 centimeters.
Place the bob between the two jaws. It should be tightly fixed between the jaws with the help of the screw provided at the top. And we have to first know the main scale reading. The main scale reading is that at which the zero of vernier crosses the division in the main scale. Here 2.4. Vernier coincidence should be taken without any parallax error one of the 10 divisions in the vernier scale will coincide with one division in the main scale. Here it is 4. The vernier coincidence is 4. Before we are going to start the experiment, we have to consider the length of the simple pendulum. Let us consider the length of the simple pendulum is 50 centimeter. That is, L is 50 centimeter. Now, we have to consider the distance from the point of suspension to the end of the bob will be A, that is 51.225 centimeter, because the radius of the bob that is measured from the vernier calipers is 1.225 centimeter. Now, displace the bob of the pendulum to some distance from the mean and release. It will do some oscillations. Take the pointer here as the mean. When the pendulum bob crosses the mean, goes to first extreme, comes to the mean, goes to second extreme, and again will come to the mean. That is one oscillation. In this way we have to take 20 oscillations, and we have to consider the time taken from this stop clock. Now let us start the counting of oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, the stop clock will show the time taken for 20 oscillations. Similarly, we have to take the time taken for 20 oscillations for the same length of 50 centimeter in trial 2. And we get 29 seconds for trial 2 reading. When the trial 1 and trial 2 values are found, we have to take the mean value and we can calculate the total time taken for 20 oscillations. Now, the time taken for one oscillation is time period. Then, capital T is equal to the mean value x by 20. We get time period. And find T square, the square of the time period. From the formula, G is equal to 4 pi square L by T square. We have to find the acceleration due to gravity from this formula. Now, let us discuss how the percentage error in small g is to be determined. Percentage error is given by delta g by g into 100. Delta g is the difference of the acceleration due to gravity values from observations and the real value. G dash is taken as the average of all the values obtained from the observation. Small g is taken from the given place, and now delta g is g dash difference of g. Then percentage error is delta g by g into 100.
Now, we plot the graph by taking L values on x-axis and t-square values on y-axis. We consider a suitable scale. On x-axis, 1 centimeter is equal to 10 centimeters. On y-axis, 1 centimeter is equal to 0.5 seconds. Now, from the observations, for L is equal to 50, t-square is equal to 2.1025. Plot the point 50, 2.1025 on the graph. Similarly, plot all the points on the graph. Now, join all the points. We observe that the line meets at origin O. Therefore, this graph is a straight line passing through the origin. Now, from the graph, we can calculate the values of L by t square and hence G. Take any point on x-axis, say L is equal to 55 centimeters and name it as C. Draw a perpendicular line at point C. This line cuts the graph at a point. Now, from that point, draw another perpendicular line to meet y-axis at a particular point B. It is 2.25. This is the t-square value corresponding to L is equal to 55 centimeters. Now, OC is equal to L and OB is equal to t square. Therefore, OC by OB is equal to L by t square, that is equal to 55 by 2.25, that is equal to 24.4. Substituting the formula, G is equal to 4 pi square L by t square, that is equal to 4 pi square into 24.4, that is equal to 963.11 centimeter square. From the graph, we can also calculate the length of the seconds pendulum. The time period of the seconds pendulum is equal to 2 seconds. Therefore, t square is equal to 4 seconds. From a point 4 on y-axis, draw a perpendicular line to meet the graph at a particular point. From that point, we again draw a perpendicular line to meet the x-axis at a particular point. This point gives us the corresponding length for t square is equal to 4 seconds or time period is equal to 2 seconds. From the graph, it is 100 centimeters. Therefore, the length of the seconds pendulum is equal to 100 centimeters.
We conclude this experiment simple pendulum after determining the acceleration due to gravity at our place and finding the percentage error in calculating G.